Hey everybody, Mr. Judson here. So we're moving on to the next section in our book. This is Chapter 1, Section 5. And one of the, we're still talking about domain, and we're even going to throw the word range in there. We want to make sure we know what those mean. It's really pretty simple. When we say domain, I really just mean x values. And it's a little more complicated than that, but if you remember nothing else other than this, you've got it. What x values can I plug into a function? We talked about a couple of conditions that we need to watch out for. Denominators cannot equal 0, and whatever's inside of a square root, it needs to be positive. Okay? So we've got some conditions on the domain. We can look at a graph and say, what x values are we covering from this point to this point? Dot, 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 all of these dots that are in between here. What x values are we hitting? And it looks like we're hitting everything between something and something. We'll get to that in a second. When we say the range, these are always y values. Okay? What y values are we hitting from this point up to here and back down again? From negative infinity all the way to infinity, which y coordinates are showing up in all of these points along this curve? That's all we're asking here. So let me give you guys just a second to think about this one. You can write it out in words. You can try and write a good mathematical expression. You can just think it in your head for right now because you're not sure what to write. But I want you to think, what's the domain and range of this function? We'll call this f of x. All right, so when I look at this, that's what I'm doing for domain. I see that I'm hitting a whole bunch of points along this curve, a whole bunch of them, and if I put dots in there for every single point, I'm going to get x values that are in between -3 and +2. But I'm not going to hit -3 because there's an open circle there. That means we're not including that point. This is a solid circle, so we are including that. So I'm going to say that x is somewhere between -3 and 2. And it's okay to equal 2, so we'll put the equal sign there. It is not okay for x to equal -3 because open circle means we're undefined. Now, let me just talk about this between statement here. When you write a between statement, you're only going to use less than signs. Less than or equal to. You never use greater than signs. And the reason for that is when we look at a number line, the smaller numbers are always to the left, the larger numbers are always to the right. This number is less than whatever x is, which is less than or equal to whatever this is. And when you write this with less than signs, we're always saying x is somewhere between those two numbers. Okay? And the second thing is, the smallest number is always on the left. Okay? -3 is smaller than 2. I don't want to switch these around. Okay? This isn't Judson's way of doing it. This is just a standard in math that we want to make sure we've got. Right? So whenever we use less than signs, and the smaller number's on the left, larger number on the right, we're really saying x is anywhere between these two numbers. Okay? You would never write, this is called a compound inequality. You would never write a compound inequality like this that has greater than signs in it. It's not written correctly. Okay? The only thing we'll ever see is less than signs. Now, if you just wanted to say, if this thing went on forever and we just said x is greater than -3, well, it's okay to use a greater than sign there. It's not a compound inequality. Compound means you got more than one inequality symbol written here. Okay? Range. Well, let's see, I'm starting down here. This point is actually at -3, -3. So my y values start at -3. They go up, they go up, they go all the way up to +3, and then they come back down to 1. Well, I'm hitting the same y values over here that I hit over here going up, so I don't need to say those twice. I just need to say I'm hitting everything from -3 all the way up to +3 on the y-axis. So y, using less than signs again, is going to be between -3 and +3. And I'm saying +3 because we're hitting the highest point right here, not here. Okay? I don't care what the y-coordinate is here. I want to know what it is at the highest point. And since I hit that point, I want to put the equal sign here. And there, I have described the domain and range of this graph. This is something that they're going to ask us to do on today's homework. Just look at a graph and tell us what the domain and range are. What are the x and the y values that are showing up in this curve? And I've done that right here. Okay, let me give you guys one to try. All right, so on this graph, I've got a picture of a circle. Not a very good circle, but it's supposed to be a circle. Centered at -2, 0, and it has a radius of 2. I want you guys to go ahead and describe the domain and range. Okay, give it a shot. All right, so domain and range. So my x values, as I go around this circle, I'm hitting all the x values between -4 and 0. Right? All negative values here, all negative values down here. So I'm going to say x is, using less than signs, between -4 and 0. And the circle does hit that point right there, and it does hit this point, so we want to include the equal part with our less than sign. So the domain is that x is between -4 and 0, and it includes those end values. The range, my y values are between -2 and +2. As we hit all these points around the circle, we got negative y values, negative y, negative y, negative y, all of a sudden 0, now positive x, positive, 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 all the way up to the top of the circle. So we're going from -2 to +2. And again, we are hitting the top and the bottom of the circle, so we want to include those. And there is the domain for that graph. Let's try one more. All right, so we've got something that's sort of a parabola-ish looking thing. I don't know if that's a word or not, parabola-ish. And we want to describe the domain and range of this function. You guys go ahead and try it. All right, so when I look at this, I'm thinking to myself, you know, parabolas, they go like this and they go up forever, but they also go out this way forever, right? You know, it's going up a lot faster than it's going out this way, but it does extend out this way forever. You know, if you think about, let's just pick the simplest parabola of all, y = x squared. There is no number that you cannot plug into here and square it. Right? If you think about our two issues with the domain, could the denominator equal 0? No, because when we don't write anything down, it's something over 1. Do I have a square root? No, I don't. So that means there's no issues. I can plug in any single number I want. So what I would say here is that x, math people use this symbol right here. It means x is an element of. Okay, x is an element of. You can write that down in here if you want. Element of. And when you make a line with an R through it, it means all real numbers. Now you could also have said x equals all real numbers. You know, if you don't know the fancy symbols, which I'm okay with that. You know, if we haven't had a math class recently, most people forget this. But you should be able to remember those words. X equals all real numbers. You can plug any number in you want. Does that mean that y equals all real numbers? Well, no. The lowest you can go on this parabola is where the vertex is, right here. And that point is at 2, -1. So the lowest y value you can get out of this is -1. All other y values are going up, so it's got to be somewhere larger than that. So I'm going to say y is greater than or equal to a negative 1. And there's my domain and range. Last time we met, Monday and Tuesday, I gave you guys rules for finding the domain. You know, denominators don't equal 0, square roots have to be positive. There really aren't any rules for a range of values. You kind of have to look at the graph and just see what's happening there. You know, what does the graph tell us? I don't have a set of rules that will get us this quickly. But if I can graph the equation and look at that graph, I can get it quickly every single time. Okay? All right. Let's try a different type of problem. All right, so one of the things that we're going to have to do in this first chapter here is we're going to have to graph functions. We've done a lot of graphing over the years, and we want to push it farther. That's what we do in pre-calculus. And so we're going to have to graph functions that look like this. By the way, I'm sorry about this. My pen bleeds, and so it's hard to read sometimes. This says f of x is equal to x squared minus 9x plus 14 all over 4x. Okay? And one of the first things we do when we try and graph is we try to locate the zeros. Because a zero is where you cross the x-axis. Those are important points that they're helpful to graphing a function. Think back to stuff you learned in Algebra 3-4. Sometimes you get questions that say find the roots of this equation, or find the zeros, or find the x-intercepts. Those all mean the same thing. Okay? Not exactly. There's some slight differences in there. Sometimes you get things that will make an equation equal 0, but you can't really graph them because they're imaginary numbers. We'll talk about that as we push forward. But in general, when we graph functions, zeros and roots and x-intercepts all mean the same thing. Okay? So if they ask me to find the zeros for this function, what they're really asking me to do is set it equal to 0 and solve. You guys go ahead and try that. All right, so one idea that we've talked about already, I tried to make a big deal out of it. I said, if I'm trying to figure out where a fraction is equal to 0, the only way a fraction can equal 0 is if the numerator equals 0. And if anyone right now is going, well, what about the denominator? What if it equals 0? Who cares? It can't, right? That's one of our rules for the domain. Denominators never get to equal 0. Never, ever, all right? So the only way this fraction can equal 0 is if the numerator equals 0. Somebody else might think, well, I'm just going to bring the 4x over here and multiply. And I'd say that's fine, because anything times 0 is 0. And so what I get then is this, x squared minus 9x plus 14 equals 0. And we talked about this last week. Don't move anything over to the other side of this equal sign. I want it set equal to 0. That's what makes this problem as easy as possible. What I want to do is I want to try and factor this and then come up with my solutions. And hey, for those who don't like to factor, I'm sorry, but it's something you have to do in math. If you haven't learned it yet, if you're still struggling with it, you've got to get it down. You know, we need factoring to be something that's easy for us to do. You can always go to YouTube and type in, factoring quadratics. And all of a sudden 20, 30 videos will show up that will help you with that, right? YouTube is a great place to learn things. And it's something that we should take advantage of, all right? Some people might, how do you find zeros for a function? And they go to YouTube and they type it in, and all of a sudden Judson pops up because I'm putting videos on YouTube. That could happen. But we want to make sure we understand it, okay? So to factor this, I'm really trying to undo the FOIL method, right? I FOILed something and I got this for an answer. Now let's undo it. So I know to get this one, I would have done x times x. Whatever two numbers go here, I would have multiplied those to get 14. I just want to think to myself, and it's important that you listen to the way I say this, what two numbers do you multiply to get 14 and add to get a negative 9? Sounds like 7 and 2, but to get a negative 9, they both have to be negative. And then we check it. X squared minus 2x minus 7x. You combine those two and you get negative 9x plus 14. And so that means that x equals 7 or 2. These are my zeros right there. Okay? Now, if they would have said find the x-intercepts, the only difference is x-intercepts are points on a graph. I would just have to write this as a point. Okay? I said let's make the whole thing equal 0. Those are my y values. F of x is equal to 0. And so that just means 7 comma 0 and 2 comma 0. If they would have asked me to find x-intercepts, that's what I would have done. Okay? Now, you know, I've been talking about showing work and stuff like that, and you know, you guys really got to get this from the samples that I'm doing. When I do an example for you guys, I'm trying to show you the best way to show your work and what a problem should look like on your homework. Most of you are doing this, okay? But there's a few people that for some reason just don't want to. I don't know, you're doing your work on scratch paper. I don't know what's happening because I can't see it. But what I definitely know is if we're taking a test, I will not give you any partial credit if I don't see the work and I can't figure out where things went wrong. You have to get used to showing that to me, okay? Whatever's happened in the past, in this class, you have to show me work. This right here is the work that produced that answer, okay? If you're going to write it down on scratch paper anyway, why not just put it right onto your homework paper? It's right there. If you ever want to come back and look at this problem and go, oh yeah, I remember that. How did I do that? You can look at your work and you can see. If you just see this and then an answer, and then you look at it and you go, I wonder how I got that answer. You've got nothing to look at, okay? You need to show the work that tells me where the answer's coming from. Okay, I've been really, really lenient with this. I'm still giving points where I probably shouldn't, but the day is coming very soon where I'm just going to quit looking at it. Nope, you didn't show me any work, I'm not even going to look at it. It's like you didn't even turn it in. Okay? You have to show me the work on where your answer comes from. Okay? Let's try another problem. All right, you guys go ahead and try this one. We want to find the zeros for this function. All right, so I'm going to set the whole thing equal to 0 and solve. I know the only way a fraction can equal 0 is if the numerator equals 0. And so now I just need to solve. Now, this time, I only see one variable. That's the only time you can move this over to the other side and try and get x by itself. Okay, so if I move 9 to the other side, it becomes positive, so 2x squared equals 9. And then I'll divide by 2, so x squared equals 9 halves. And now I just need to take the square root of that. Remember, I'm looking for two answers. So x is going to equal plus or minus the square root of 9 halves. And of course, I know people are thinking this right now. Do we have to simplify those square roots? And the answer is yeah, just like we have to reduce fractions. You know, that's something we've learned. We've been doing it for years now, and it should just be automatic. Don't ever ask, do I have to simplify this? Anytime you ask that question, just assume the answer is yes, and you got to do it. Okay? So to simplify this, I've got plus or minus the square root of 9 over root 2, and the square root of 9 is 3, so I get plus or minus 3 over root 2. And then we have this rule that says you cannot have square roots in the denominator. So we have to do what's called rationalizing the denominator. And you just do that by multiplying by the exact same square root that you see written there. Okay? So now what I have is plus or minus 3 root 2 over square root of 2 times the square root of 2 is really the square root of 4, which is 2. And there it is. It is simplified. There are my zeros. And again, what we mean when we say that is, if I take these two numbers, positive 3 root 2 over 2 and negative 3 root 2 over 2, if I take either one of those and plug them back into this problem, I'm going to get 0 for an answer. Now, one thing you probably do want to just double check is make sure that when you get an answer, I don't plug it into the denominator and get 0. Because if you do, you have to throw that answer out. Okay, that's a really easy thing to miss. But we should always just, kind of look at this and go, okay, x can't be 3. Well, that's not 3, so we should be okay. All right? Let's try another one. All right, let's find the zeros for this function. All right, so I'm going to set it equal to 0. I don't have a fraction this time, so this is different than the last two problems. What I need to do is I need to factor this, and I'm going to have 3 factors. And I got to be able to figure out what they are. So we did a problem kind of like this last week. We called it factoring by grouping. Okay, I got to look at the first group and the second group and ask myself, what could I factor out of this? I could factor an x squared out of there, and I'd be left with x minus 4. I want to get the exact same set of parentheses here, x minus 4. I've got to find a way to make that happen. So if I factor out a negative 9, so divide this by negative 9, I'm left with x. 36 divided by a negative 9 is negative 4. If you multiply back, you should come back to what we had just a second ago. And then when I still look at these two groups here, what they both have in common is this set of parentheses, x minus 4. So I'm going to factor that out. And what I'm left with is x squared minus 9. And now my question is, could this be factored farther? And the answer is yes. This is the difference of two squares. There's a factoring pattern for that. X plus 3 times x minus 3. If I FOIL this real quick, I would get x squared. And then I get negative 3x plus 3x. Those add up to 0. That's why I don't see an x term here. And then positive 3 times negative 3, that's negative 9. So my zeros are at x equals 4, negative 3, and 3. There it is. We found the zeros. These are the x values that if you plug them into that function, you're going to get 0 for an answer. So what if we had to do this on our graphing calculator? Let me get my graphing calculator set up. So what if I was using my graphing calculator as a way to find zeros? All right. So I would go ahead and graph that function. So I'll go to y equals. Let me just clear this out. I'm going to graph x raised to the third power, and then minus 4x squared minus 9x plus 36. Okay? And then I'm going to hit, we'll talk about this later, but I always go zoom option 4. It's always where I start with everything. And I want to see if I can spot these 3 points where my graph hits the x-axis. And it looks like you can see those here. Okay, if I want to change my window just a little bit, and I should, right? because I'm going to refer to something that's called a complete graph. Okay, I'd probably write this down somewhere. A complete graph means you can see all x and y intercepts, and you can also see all the high and low points. I can see a low point right here, but I can't see the high point. So I should change the window. And what window means on the graphing calculator is how much of the xy axis do you want to see? How much of that coordinate system? All right? I need to see up a little higher. So I'm going to, let's see, I'm going to take this right here and I'm going to say, let's just call that negative, let's just go -6, whoops, to +6. Just trying to get some nice, neat numbers here. For my y values, I think -4 was fine. And I need to go higher, so I'm going to go up to like 10. And then I'm going to graph it again. Well, still not good enough. So let me try this again. Window, I only need to change one number this time. I need to go a little higher. Let's go as high as 20. Still not high enough. Let's try it again. 30. See how on the y-axis my tick marks are starting to get really close to each other? I'm going to want to change that. Okay? So let me do this one more time. I'm getting tired of going by tens. Let's just go all the way to 50. It should fit in there. But now what I'm going to do is I'm going to say, let's put a tick mark every 5 units so I don't see as many of them. And so now at least my y-axis looks a little bit cleaner. There we go. I now have a high spot. There's my low spot. I can see my x and y intercepts. That's a complete graph. Okay? We're going to have some problems today. They're going to tell us to use our graphing calculator to find the intercepts. And so we've talked about this before. Anytime you use the calculator, you want to draw a window that shows what you're looking at. My x-axis is way down here. My y-axis is right here. I went from -6 to +6 on the x-axis, and I'm going from -4 up to 50 on the y-axis. I don't care about the tick marks. You don't have to put those in there. And what I got was a graph that looks something like this. Okay? And we want to verify that this is where our zeros are, our x-intercepts. And so how do you do that? Well, one way is you use this calc option. Okay? Now, we're doing a lot of stuff on the graphing calculator here, you guys, right now. You should be writing all of these steps down. Okay? You won't remember this in 2 days. You'll sit there and go, what did Judson do? And these are things we have to do on the Central Washington test. Okay? So we want to have these steps down. So I'm going to go up to this calc option, second calc. And what I'm looking for is a 0. Okay? I'm only going to do one of these. I'll do it for 4. Okay? I know I've got one at 4, I've got one at 3, and I've got one over here at -3. So I'm looking for a 0. I'm going to hit enter, or I could just hit option 2. And it's going to ask me, what's the left boundary? So when I look for 4, I need to get a number on the left side and on the right side. I need numbers on either side of this. So I don't want to go all the way to 3 because I might pick up this answer. So for my left boundary, I'm going to go 3.5. And I hit enter. Okay, now on my screen it says the answer is somewhere to the right of that. Now what's a right boundary? Well, I can't go past 6, but I've got to choose something larger than 4. Let's just go 5. And I hit enter. And then what it wants us to do is to give it a guess. And so I'm going to go like this. I'm going to kind of arrow over. See the cursor on my screen? I'm going to get down close to 4, but not exactly at 4, because I just want to see if the calculator can do it. And I hit enter, and there's my answer, 4, 0. So I just verified that that is a 0. Okay. Now, if it was some decimal number, well, then I'm going to write down that decimal number and just round it to 3 digits. Okay. And they're going to ask you guys to find zeros on the calculator today where you have to round them to some decimal number. Okay? Let's try something different with the calculator. All right, we want to find the zeros for this function using our graphing calculator. And anytime you see me write down GCalc, that means graphing calculator. All right, you guys go ahead and try it. All right, so I've got my function typed into the calculator. Anytime you hit a square root, to get out of it, you have to hit the arrow key. All right, and it'll pop you out, and then you can add whatever else needs to be added to that. So I always start off with zoom option 4, just to see what happens. So let's see what pops up here. Nothing. So just kind of looking at this, I'm thinking to myself, I'm probably going to have some positive number here that I need to plug in here to make this equal 0. I'm guessing. Let me go out a little bit farther in the positive direction. And this is a very normal thing with a graphing calculator. I graph something, I don't see it, so now the question is, where is it? Okay? Here's what's happening. Here's the XY coordinate system, and what we're doing is we're looking at this section right here, but our graph maybe is out here somewhere. So I'm just not looking at enough. I need to expand the window and see a little bit more, okay? So I'm going to go zoom, and I'm going to choose zoom out, and I'll just hit enter. And then I got to hit enter one more time because they want to know, what do you want at the center of your screen? I still want the origin at the center, so I got to hit enter to tell the calculator that. Ah, there it is. And see, we're crossing the x-axis way out here somewhere. So now I'm going to set up my window. I'm going to say, let's go from 0 to, I'm going to go to 50. And I'm going to count by tens. That's what the scale here means. I want to see a tick mark every how many units. And then for my y values, I really don't need to go that far. If I just go from -5 to +5, and I'll just count by ones. That should be good. I just need to see where it crosses the x-axis, right? So as long as I got a negative number and a positive number, I'll see that. All right, so I'm going to hit graph. There it is. So I now have a calculator window. Here's my x-axis. You can put arrows on it if you want. Here's my y-axis. And I went from -5 to +5 on the y-axis. I went from 0 to 50 on the x-axis. And my graph looks something like this. And I'm trying to find this point right here. There's only one 0 because it only crosses the x-axis once. And so I'm now going to do second calc, option 2, we're looking for a 0. I need to give it a boundary. Okay. Well, there's only one number in there, so I could just say 0 is the left side, 50 is the right side. I just have to stay inside the window that I set. If somebody wants to go, well, it's really between 20 and 30 because you counted by tens, Judson, I'd say, okay, let's do that. 20 is my left boundary. 30 is my right boundary. And now give it a guess. Okay, right there. Even though I know it's not a good guess, it'll still find it. There we go, 26, 0. So I have a 0 at x equals 26. There it is. Now again, everybody should be looking at this and paying attention to how you show your work, right? I'm not just going to write this down and then boom, there's my answer. I'm showing a picture of my graphing calculator window so that when I see that I go, oh, you graphed it, okay, there's what you saw, and you calculated the 0 and there's what you got, and so that's why you're saying that. And I can see all that, right? The communication piece is there, and I know exactly what you guys as students are talking about. So we need to include the work that goes with this. Just like when we did our Walmart and basketball, we needed to include a picture of the graph, the equation it gave us, and then our final answer. We're still doing the same thing here. All right? Okay. All right, so here's our assignment. Assignment number 4, this is continued. So, the work that we did from Monday and Tuesday, combined with this will be due next Wednesday. We're on page 61 to 62, and we're going to do 1 to 29 odd. All right, that's it. You guys have a good day, have a good weekend, take care, make sure you're staying safe. We'll see you next week.